Okay, so I've drawn a track here that's very similar to the problem that's on your sheet. I've just changed the numbers. So instead of a mass of 10, I have a mass of 2, and then I've changed the heights of the track as well. But the letters are the same, and the shape of the track is the same. Okay, so your question wants you to find the potential energy, the kinetic energy, and the total energy at each of the following points, A, B, C, and E, but not D because D doesn't give you a height. So I'm going to start with point A. It says that the cart is stationary at point A. That means the velocity is 0. So if I look over here at the kinetic energy equation, if the velocity is 0, the kinetic energy is also 0. So I don't have to calculate anything, I just know it's 0. The potential energy depends on the height. So this equation says it's the mass times gravity times height. The mass is 2. Gravity I'm rounding to 10, or you could use 9.8. And the height they gave me is 50. So that's 2 times 10 times 50, which equals 1,000 joules. I know that's a little bit small, but it's 1,000 joules. So the total is just the potential plus the kinetic, so that's 1,000 plus 0, so that's 1,000 joules. Yours will be different numbers, but the setup is the same. Now, conservation of energy tells us that this total energy is never going to change. As it goes downhill, it's going to lose potential energy and gain kinetic, but the total never changes. No energy lost or gained, it's just transferred between potential and kinetic. So since the total never changes, I can go ahead and fill in 1,000 joules for each one of these. Like so. So I know the total is never going to change from 1,000. It's always going to be 1,000. Again, your numbers are different, but the concept is the same. Okay, so now I can start filling in the rest of the points. At this point B, the height is 0. So if H is 0 for potential energy, then potential energy itself is also 0 joules. So the kinetic has to be 1,000. Notice I just did 1,000 minus 0, all of its kinetic energy, so it's 1,000. If we move on to point C, the height is 20 meters. So I have the mass is 2 times 10 times 20, so that's going to come out to be 400 joules. I know my total is 1,000 and the potential is 400, so if I subtract those I can find the kinetic because potential and kinetic have to add up to 1,000. So that must mean the kinetic is 600 joules. All right, for the last one, the height is 15, so that's just mass is 2 times 10 times 15, so that's going to be 300 joules. The total has to be 1,000, so 300 plus something equals 1,000. The kinetic energy then has to be 700 joules. So that fills in the first question, potential, kinetic, and total for each of those 4 points. Now the last question asks you to find the velocity at point E. So the kinetic energy equation has velocity in it. We know the mass is 2, and the kinetic energy we already found is 700. So this sets up as 700 equals 1/2, or you may have written it as 0.5 times 2 times v squared. So if I do the math for that, that'd be 700 equals v squared. 0.5 times 2 is 1. So then I can just take the square root. And that would give me the velocity. I'm not going to work that out, but because yours would be different, but this is the same setup.